Hey guys, Mr. Ground with another challenge video. So 8-2 day 2, this is going to be multiplying and dividing rational expressions, except it's going to be the more difficult factoring that we covered in the factoring review challenge. Okay, so taking a look at this one, pause and try it out if you think you got it, and then unpause when you're ready. And we are going to do the identify the x values for which it's undefined for this one, just because it's a challenge video. Okay, so we'll split this up and we'll do it one piece at a time. So taking this one first, that's actually pretty easy. Oops, not an x squared though. X comes out and x minus 6 stays in. It's a GCF factoring. Then we've got our quadratic form, right? So it's a difference of squares, but now instead of x, it's x squared minus 3 and x squared plus 3. Then on the bottom, we've got some grouping to do. So this one can factor by grouping. First part, an x squared can come out, and it's x plus 9 that stays in. Then the second part, a 3 can come out, and it's x plus 9 that stays in. And then the next step to finish this off, it will be x squared plus 3, the stuff out in front, and x plus 9, the stuff in the parentheses. All right, and then we've got a voodoo factoring one. This one, so we move the 4 over, my x squared minus 19x minus 120. Now we need two numbers that multiply to a negative 120 but add to a negative 19. This one we could actually probably start doing the factors because it is a little bit trickier. So just taking a look at these. Now I know that one of the numbers has to be negative because the product is negative. I know that the bigger number has to be negative because the sum is negative 19. So it's got to be like one of these. So 4 and negative 30, 5 and negative 24. There, we found it. So this will be x plus 5 and x minus 24. Not done yet. Let me get rid of that because I'll need that space. We'll undo our multiplication by dividing by 4. And what we have in the end is 4x plus 5 and x minus 6. Okay, so now use your imagination and imagine that this is rewritten as one big fraction, where this is the top and then this is the bottom of the first one, the one on the left. This is the top and this down here is the bottom of the one on the right. We can then start canceling some stuff out. So this x minus 6 way up here cancels this x minus 6 way down there. X squared plus 3 cancels this x squared plus 3. And everything that remains is our answer. So x times x squared minus 3 all over x plus 9 and 4x plus 5. Now, looking at the domain restrictions. And just because it's a challenge video, we'll include the complex domain restrictions. Why not? All right, so looking at this one that canceled out, x squared plus 3, if we set that equal to 0 and solve it, we get minus 3, x squared equals negative 3. When we square root both sides, we get that x can't equal, it's a plus or minus because you're square rooting both sides. Then the negative makes an I come out and root 3 doesn't simplify. So the way we would write that plus or minus I times root 3. Okay, so that's that one. Then the rest of them are a little more straightforward. X plus 9, we can just switch the sign there, and that is negative 9. 4x plus 5, to save time, let's look at the step above it, right? X plus 5 over 4, this has the same solution, so if we switch the sign there, it is negative 5 over 4. And then the last one would be from the x minus 6, we can just switch the sign and make that a positive 6. So look at all those lovely domain restrictions. All right, next one, dividing. Whoa. Again, pause if you want to try it. Otherwise, forge ahead here. All right, we're going to do the factoring and the keep change flip in one just to save some space. So looking at this first, the top one here, we've got our quadratic form. We're looking for two numbers that multiply to a positive 6 but add to a negative 5. And because they need to make x to the fourth instead of x, it's going to be x squared. So x squared minus 3 and x squared minus 2 all over x plus 3, nothing doing there. Then we're going to change it to multiply. Looking at the bottom one here, that negative in front of the x is kind of a hint that it's really a GCF one, right? I can factor out a minus, and then look what happens. If I take the minus out, it's going to change it to a positive 3 and a positive x and a plus 3, and now I've got x plus 3 and x plus 3 that will cancel each other out. Let's see, and then the last part will be the x to the fourth minus 4, which will factor it and write it down here, right, because we're doing keep change flip. And so that is going to be x squared minus 2 and x squared plus 2. Okay, canceling. The x plus 3's cancel, the x squared minus 2's cancel, and what I have left, don't forget about that negative on the top right. So it's negative on the outside of the parentheses and x squared minus 3 on the inside. You could distribute it and make it negative x squared plus 3 also, and that would be correct. And then x squared plus 2 on the bottom. Now, when it comes to the domain restrictions, this is where it gets a little bit interesting, because if I'm dividing by a fraction, not only will this be undefined if the bottom of the fraction is 0, but it'll also be undefined if the top of the fraction is 0. So you know, bear with me here and let me explain this. This fraction over here, right? This part of this expression is undefined if this is equal to 0, the denominator, okay? Then if we look at the other fraction, this one is undefined if its denominator is equal to 0. But then because we're dividing by this, if we're dividing by something that equals 0, meaning the top equals 0, then the whole thing is also undefined. So we've got 1, 2, 3 spots where we have to like account for our domain restriction. So really anything on this right side, any factor that from top or bottom here is going to create potentially create a domain restriction. Okay, so looking at the x plus 3 first, well, I've got x plus 3 here and here, so that actually isn't so complicated because it's the same 0, right? That will just be a negative 3. And if we look back at the original before we factored it, right, if I plug a negative 3 into there, negative of negative 3 is positive 3, then you subtract 3 and it equals 0. All right, so then the next part, we've got two of these little quadratic binomials. So x squared minus 2, where does that equal 0? Well, if I add 2 to both sides, I get x squared equals 2. Take the square root, and I get x is plus or minus root 2. So plus or minus root 2 are domain restrictions. Now, if I change that and we make it a plus 2, then we're going to get some complex ones again. So minus 2 on both sides, x squared equals negative 2. Take the square root and we get x equals plus or minus I root 2. So negative 3 plus or minus root 2 and plus or minus I times root 2.